All right, well, good evening, everybody. I have to start the happy hour for our next IGS BS session. Welcome. We've got a great lineup of speakers and panelists tonight that I think we're all really excited to hear from. We wanted to take this evening to visit a little bit about specific approaches and tips that breeders can do to improve the quality of information that's being fed into the genetic evaluation. And, so we have a team of scientists that we work with and collaborate with, and this group is kind of constantly cranking on the system and tweaking and trying to make improvements and improve methodology and improve statistics, and lots of work is happening behind the scenes. But at the same time that wheel is turning, we want to rally the group of breeders that's using the IGS genetic evaluation to do the best that they can and learn the most that they can about turning in quality data. So tonight we have an outstanding lineup of speakers that have a lot of a wealth of information in this area. We have Ryan Bolt, who is the Director of Breed Improvement with the Red Angus Association, and also a PhD candidate with CSU. And Ryan, I don't know when you're going to be officially Dr. Ryan Bolt, but certainly making your way through that process. We also have Dr. Bob Weber, who is joining us from Kansas State University. Bob is a well-known name in animal breeding and beef cattle genetics, and offers a wealth of knowledge on this topic, both hands-on and academic. We also have three panelists that have been recommended from some of the breed associations that we work with. And these are breeders and folks that work at feed stock operations who are doing this well. They really are paying attention to data collection, performance information, and really thoughtful about the information that they're sending into the genetic evaluation. So we'll have Kevin Porter from Alberta, Canada, with Porter Ranches. We've got Toby Jordan from Indiana in Wakuru. I didn't say that right again, did I? Sometime I'll get it right, Toby, but maybe not tonight. Well-known name in shorthorn feed stock operation. And we also have Casey Santa, who might not be showing his video quite yet, but Casey works with wolf cattle and is an integral part in their data collection process as well. So tonight we'll kick off with Ryan and Bob, and then we'll open it up to more of a conversation. One thing I'd like everybody to be aware of is depending on how you logged on to this meeting, there's a little hand held up by your name of attendees. And if you would like to speak, you can raise your hand and we'll click on that and you'll be able to ask questions. If that option is not available or you would rather not be the one asking the question, you can click the little question mark and type in a question to us. Either way, we'd love to hear from you. We'd love to take questions from you, and looking forward to having this as a conversation. So with that, Ryan, I think we ought to start seeing your screen.
Did it show up for you, Jackie?
It's a blank white screen.
Well, that's not going to work. It says it's sharing.
There we go.
Oh, there it is.
Oh, we got presenter mode, Ryan. There. Now we're set.
Now we're good. Okay. Well,
yep.
Finally figure out how to drive this. So we'll do our best. So, well, thank you everyone for attending the presentation and the resulting kind of panel or roundtable discussion, and look forward to any questions that we have you know, whether that be for myself or Bob or some of the panelists as well. And so kind of what we're going to focus on tonight and talk about is, you know, collecting data and phenotypic information and how that's used within a genetic evaluation and maybe the best way to put that information into a database so it's the most useful within a genetic evaluation. And so I'll be giving part of this presentation, and then Dr. Bob Weber will also be sharing some of his thoughts and insight on those things as well. And so kind of, you know, being a geneticist, I think one of the requirements is every time you give a presentation that you have to put some sort of equation in there. And so I'm just going to start right off with that. And luckily, most of my equations aren't too complicated tonight. And so, you know, but we'll try to get a few incorporated in there. And so everyone's seen this equation before. You know, as we think about a phenotype of an animal, so that's a trait or some sort of measurement that we can observe or measure within an animal. Really, there's two kind of main factors that affect that, and those being the genetics and the environment that the animal experiences. And in true, you know, form, we can make that even more complicated because that seems to be something that we like to do sometimes. And so, you know, as we think about our genetic portion of that equation, we can break that down into, you know, kind of two more parts. And the first being the additive genetics, which that's the portion of genetics that's passed from one generation to the next. And that's really what we're trying to focus on in terms of our EPD calculation is trying to get a good measurement or provide a good prediction of an animal's additive genetic value for different traits of interest. Another part of this equation in terms of genetics is the gene combination value. And so this gene combination value is not something that is passed from one generation to the next. And so it's something that we focus on in trying to take out some of that variability in terms of that when we do the EPD calculation process. Tonight we'll do a bit of discussion about contemporary groups as well, and so one of the big driving forces of contemporary groups and what you're trying to identify with that is environmental influences over different phenotypic observations. And so as we think about maybe some of these environmental effects or things that we're trying to look at estimating in terms of contemporary groups, those might be things like permanent environmental effects, which we would think is something that, you know, maybe something environmental that affects an animal over its entire lifetime. And so kind of the common one that I was always told was, you know, an example of this would be fatty udder syndrome in overdeveloped heifers. So that, you know, that overdevelopment process would affect every part of or every future lactation for that female. And so that might be an example of a permanent environment effect. You know, again, there's temporary environmental effects as well, which those are kind of more short-lived sort of environmental effects. So that may be something like an animal gets, you know, a little sick before measurements taken. But, you know, really that's kind of how we break down these phenotypes and how we get to what is observed in terms of our phenotypic measurements is some of those different things. So, you know, why is data important? And you know, I have a lot of conversations with our breeders here at Red Angus as well as different IGS partners, I'm sure do with their members as well, of, you know, why is data important? You know, really the reason data is important is because that's what really drives the EPD calculation process. And so as we think about, you know, what goes into an EPD or what I call the pillars of EPD calculation, you know, there's kind of three main things here. One being the pedigree information on an animal, the second being the phenotype information, so the actual submitted phenotype data that goes into a genetic evaluation, as well as more as well as genotype information that we now have the ability to include in a single step genetic evaluation. But as we look at, kind of two of these three pillars, we can kind of view those as adding additional data and information into that EPD calculation process and trying to make those as precise as we can. As we think about the pedigree side of this, that's really the way that we use to relate different data or pieces of information to one another. So as we think about our pillars, 2/3 of these are really driving data and information into that EPD calculation process. So the first part that I'll talk about here is kind of a data collection step, and maybe at different time points through an animal's lifetime, what data points we would be looking at collecting at those different at those different ages, and this is not only on those individual animals but maybe the dams as well, and just kind of going through and putting together a list of different traits that we could look at measuring. This is kind of our current list now, and you go to listen to BIF every year and things of that nature. This list will probably continue to grow as time goes on, but really what we'll kind of go over here is a lot of the core or commonly recorded type things. So the first opportunity that most animals have to receive any sort of phenotypic observation is when that animal is obviously born. And so we look at taking these measurements within the first 24 hours of birth. And so kind of what we're looking at collecting there is obviously the birth weight of that individual animal, the Cavity score recorded, whether or not that dam required any level of assistance using kind of our standard 1 to 5 Cavity scores, as well as on the dam of that individual calf. That's the time that we want to try to observe different teat and udder scores and record those on those dams. The second kind of portion or time point that we look at as another opportunity to collect some phenotypic data or phenotypic measures on an animal is around weaning time of the animal. And so, unlike birth data, we generally look to collect most of this data when kind of the average of the group of calves is around 205 days of age. And so kind of our recommendation at Red Angus is to try to target that data collection when the group is 160 to 250 days of age, just so we can try to get as many animals around that 205 age distribution window as we can. The reason for that is when we calculate EPDs or even show things in the database is we age adjust a lot of those measurements. And so being able to have animals within that age window definitely increases our ability to accurately adjust those ages to a constant day of age. And so as we look at, kind of different phenotypic measurements that we can collect around weaning time, obviously a big one in terms of, calves that are born is weaning weight. And so, a lot of people will be collecting data and information on the weaning weight of those animals at the time. As we look at the dam side of it, that's also kind of the recommended time to take dam weights, as well as dam body condition scores. You can collect dam hip heights, and then kind of more recently we've talked about adding another phenotypic observation opportunity there of collecting feet and leg scores on mature females, and that might be an opportune time to try to do that. And then also, some breeds do collect docility scores at weaning time, and so that's an opportunity to try to collect those docility scores. Kind of our third time point here that we're going to talk about, in terms of looking at data collection, for a lot of your animals is in that kind of post-weaning yearling time frame of animal or age. And so as we look at most of those yearling weight type or yearling type measurements, we're going to again want to try to target collecting those observations at around 365 days of age, and really wanting to try to hit that kind of target window so we're able to age adjust those for, you know, the genetic evaluation. And you know, as we look at maybe some different traits that we can present or have or collect at that time, you know, one obviously being yearling weight observations of that animal, another being our different ultrasound measurements, so that whether, you know, that being IMF, ultrasound back fat, and ultrasound ribeye area. The again, kind of going back to feet and leg scores, this is an opportunity on younger animals, maybe not mature females, to begin collecting some of those feet and leg scores. You can look at heifer pregnancy and heifer exposure information, collecting that around that time, dry matter intake, hip height, and then, you know, most people are doing this in preparation for their bull sale, but looking at a breeding soundness exam for bulls, taking things like scrotal circumference, things of that nature. And then on the female side, we can look at and maybe some reproductive tract scores, as well as some pelvis measurements, and then again some docility score. And so, you know, as we look at each of these three different kind of time frames or different age windows that we're looking at trying to collect these different phenotypic measurements, you know, there's a lot of opportunity to be able to collect these different measurements and include that data and information into the genetic evaluation. And so, you know, as we think about, you know, a lot of the things that we look at or take measurements on, or most commonly take measurements on, are weight type measurements. And so, you know, kind of as I was putting this presentation together and thinking about this, I thought about maybe some best practices or some things that could be, you know, used to try to make those weight measurements as accurate as we possibly can. And so, you know, probably a very important and obvious one is to make sure to calibrate the scale prior to taking those weight measurements. You know, we want those to be as accurate as we possibly can. You know, the second thing that sometimes gets overlooked, and I know it's usually probably pretty busy days when we're trying to collect a lot of weaning or yearling weight information, but, you know, is important to try to pay attention to is to look at cleaning that scale or cleaning out that scale, you know, periodically throughout the day. We don't want to get too much manure built up underneath there or things of that nature that could, you know, throw off our weight measurements throughout the day. Another one that I think, you know, sometimes gets overlooked as well is looking at taking empty body weights. And so, you know, as you think about animals and rumen fill or gut fill, that, you know, there's a certain percentage of that weight measurement that can be attributed to, you know, just differences in gut and body fill. And so, you know, if we have the ability to maybe withhold feed or water from those animals and take multiple body weight, or excuse me, take empty body weight measures, hopefully then we can kind of minimize some of those differences that are attributable to, you know, whether or not an animal went and got a drink prior to taking that weight measurement. If you want to get a bit more extreme, you know, you could look at taking multiple weight measurements and averaging those. I know that's, you know, done a lot when we're looking at taking data and information for on feed intake type trials. This also may help you identify, you know, an animal that did have, you know, a dramatic difference in terms of, you know, gut fill from one measurement to another, and identify those animals on weigh day that have a little different, you know, variation in terms of that. You know, and the last thing here is, you know, weigh as many animals as you can in one day. As we think about wean weight and yearling weight type information, generally part of those contemporary group parameterizations is animals that were weighed on the same day. And so, you know, to kind of maximize the size of those groups as well as try to, you know, minimize differences in environmental effects, we're definitely going to want to try to weigh as many of those animals as we can on that single weigh day. The other, kind of piece of data that I get, or questions that I get from time to time, is subjective data or rubric type scoring data, and questions, about what's our best method or metric to try to make sure that we're doing that as accurately as we can, and I, that it's always kind of maybe a little challenging to come up with, good ways to guarantee accuracy on that. But, this is kind of, I guess, always my recommendation. And one of those is to always, when you're looking at taking some of those measurements, to have that rubric for those different, observations available in front of you, just kind of as a second check, especially maybe if you're, looking at between two possible scores. Another important thing is, as you're looking at subjective type measurements or scoring type data, the biggest thing there is to try to be consistent within your scores. And so, we want to be able to have, consistently, really within this type of data, what we're trying to look at, or really any data overall, is differences. And so as long as we're consistent within the way that we're scoring these different subjective data points within, a contemporary group, those differences are really the more important part, maybe, than the absolute value that you assign that individual animal. Not getting that absolute value is not as detrimental. It's more about the differences among those different observations. And so, being able to be consistent and score those animals consistently throughout the day is definitely very important. There's certain different metrics that we may have been doing for a very long time, maybe taking body condition scores for longer than I've been alive. And, we may think that we know those, like the back of our hand, but I would definitely recommend that it's always worth, before you go out and look at some of this data or trying to collect some of these data, try to make sure that you're still being, consistent in that scoring and being able to identify, those different scores accurately, even though you may think that you know it like the back of your hand. Another option as well is taking kind of paired observations of some of these subjective measurements. So, having multiple people score the same animal, and then looking at, kind of taking an average of those different observations and using that as a phenotype for some of these subjective kind of data points. And so, those are kind of some options that I see, as different ways or best practices that you can do to kind of work on some of this data. And so, now we'll kind of move in, we've talked a bit about maybe some of the different data points that you may look at recording, on your animals throughout the year, and at what different time points, you probably want to record that at. And I'll turn it over to Bob now, and he's going to talk a bit about, reporting that information to your breed association and some of the best ways to do that. Should be good to go, Bob.
Great, thanks, Ryan. The comments you made there, I think, are really good in terms of setting up the data collection process to be as informative as possible for the genetic evaluation. And so, systematic things we can do to reduce bias in data recording, whether that's, you mentioned cleaning out the scale. That's one of my pet peeves on the planet. It's you work on a research project, and the grad students don't clean out the chute periodically. It affects the results, right? And it's there's enough standard error in all the things we do. Working systematically to eliminate as much of that as we can be really, really important. I'm trying to get to the spot where I can advance the slide. Maybe I'll just hit the button and see if it does it.
Said you should have access. If you do your space bar, does it maybe work?
Yeah, I tried that, Ryan. Oh, here it comes. I got the arrows now. All right. We'll see if we can get it. Well, they went away. Now they're there. So I think, as Ryan pointed out, the data recording exercise, we have a tendency, and Ryan and I talked as we were getting ready, we talked through this a little bit, and I think it's one of the challenges we face as data recorders, and I fall into the same category as a seed stock producer. We get really focused on the individual animal, and sometimes it's really useful to step back and think about, data collection from the group or the processing batch sort of perspective, and we capture some of that information in the contemporary group, and we really need to do as good a job as we can in forming contemporary groups, and we'll talk through that here in a little bit. But really our data collection effort is to try and capture individual data, but as we do that, what we want to try and do is provide as good of information on the contemporary group as possible, and we'll talk about that as we go through this next segment. And it really comes down to the importance of contemporary grouping and getting appropriate contemporary group structure, because contemporary grouping really defines the equal opportunity of animals to perform. So getting that formed correctly, both in the data that's submitted to the organization in terms of management information and so forth, birth dates, etc., is important. But we also consider age of calf and sex in those determinations. So good birth date data is important. Making sure we get genders right. Occasionally we'll find animals that get recontemporated because of wrong gender recording. So sometimes it's typographical or transcription errors in data submission, but sometimes it just got wrote down wrong in the calving book, right? And so doing as good a job as we can to capture that information as it's recorded and submitted is important. And really I like to focus on the idea of contemporary grouping, because it's the basis on which we make all comparisons in genetic evaluation. And we get a lot of questions. I'm sure Ryan is a new breed staff person, and Matt gets lots of questions about EPD calculation and how the systems work, and I certainly did as a staff member as well, and continue to in extension. But really the core idea in our existing national cattle evaluation system is the comparison of contemporaries. And the way we do that is, and Ryan pointed out the obligatory equations, and we've done as good a job as we can to make it really simple math today. And this is an idea that I think producers really need to get ingrained in their thinking, and it's that the phenotype of an animal, and Ryan explained it as genetics plus environment. I'm going to change and I'm going to swap environment for contemporary group, because in the national cattle evaluation, contemporary group mean, or the average performance of the adjusted records in a contemporary group, become our estimate of environment. That's the numeric data that gets used in the genetic evaluation to reflect environment in which that record was recorded for all animals in that contemporary group. And so it becomes really important. And so at the bottom of the slide there, I've sort of reformed Ryan's equation to say phenotype equals contemporary group plus genetics. If we do just a little bit of algebra, we can rearrange this equation to get at the idea that genetics are really an expression that are the result of the phenotypic record we record on an animal less the contemporary group mean. Okay, and so we calculate a set of deviations in effect for each animal in a contemporary group by deducting the contemporary group mean from its own performance record or adjusted performance record. And because of that, contemporary group becomes constant. It's the idea that, if we have a group of animals that have all had equal opportunity to perform, so they've had the same feed, same management, same animal health protocols, so forth, that part's constant, right? It's constant across the contemporary group. And in this mathematical formulation, the CG that you see there is that contemporary group mean. It's the average, and it's a constant relative to every animal in the contemporary group. So if we think about things that might potentially mess that up, it's obvious that if we have anything that affects adversely the reliability or the precision of a contemporary group mean, it affects every animal in the contemporary group. Okay, and so doing a good job of building and forming and measuring data of animals in a contemporary group becomes really essential in terms of reporting quality data to a genetic evaluation system. So I get to the next one. So some tips. Oops, we went too. Punch the button twice. So some tips for contemporary group reporting. I think one of the most basic ones is really know what your breed association uses to define a contemporary group. In broad sense, this is herd year season. So, your breeder number, the year those records were recorded, and the calving season in which the calves were dropped. And that may be a very defined period of time. So I remember when I worked at the Gelbvieh Association, there was a calving window applied at the University of Georgia that basically caught winter calves that were born December, January, February. And so each quarter of the year, but not starting in January, it started in December, defined part of the contemporary group rules. Work orders, so the batch in which data is submitted is an important component. So, if you weigh 5 calves today and submit that data, and you weigh 20 more calves in a week and submit that, those may land, depending on your breed association's processing, in separate work order numbers, and that becomes potentially a break in the contemporary group. So having a good idea on how your breed handles that data is really, really important. Obviously, age windows. So Ryan talked a little bit about the windows around weaning weight and yearling weight. Working to build groups, even if it means multiple weigh dates, to maximize the number of calves in a contemporary group is advantageous. And then being cognizant of previous contemporary group assignments. So recognizing that contemporary groups after birth traditionally get smaller, not bigger, because of these sort of segregations of animals within group into subgroups. Making sure you understand the impacts of, let's say you wean calves and then you take a group of them and put in and feed them for exhibition at, say, the National Western. It's inappropriate to contemporary group those with the bulls that are group fed, a separate diet, in a different pen. So making sure that we have recognition of that differences in environment and management. You shouldn't put those back, or try and put those back together into one big group. Okay. I like to focus on exceptions to typical management as a way to simplify contemporary group formation. So I set an example here just a second ago on show cattle. Chronic sick calves should get coded so they get pushed off in single animal contemporaries groups. Embryo transfer calves, breeds have a little differing rules depending on how that data gets into their genetic evaluation on how embryo transfer calves are handled and whether they're out of registered dams or unregistered recipients. First calf heifers and partitioning those if they're managed separately. And I know IGS is going through a process in the new work order that's going to define first calf heifers as a separate contemporary grouping criteria. But historically, those breeders have been able to include those first calving heifers in contemporary groups with their mature counterpart, or the calves of those mature counterparts contempt together. So just having an idea on what things did you do different in your herd management throughout the year, and how that might influence individual calf performance is an easy way to sort of help resolve the complexity of this problem. The defining question is, were they given an equal opportunity to perform? If your answer to that question is yes, if you've got two calves that are potentially different contemporaries, if they were given the same opportunity to perform, cows that may have grazed the same range, they were weaned together, they were managed in the same cohort post-weaning, clear on to maybe the feed yard for some carcass data, same contemporary group. If there was something substantial about the difference, say you set a calves to the slaughterhouse or to the feed yard as calf feds, and then you backgrounded another group and sent them later to the feed yard, different opportunities to perform should be in different contemporary groups, okay? The thing to recognize, though, is that we can take this too far, right? And so we recognize that it's important to define real differences in environment, but if we've got, let's say, two groups of cows, they're on a similar range, say adjacent pastures, same stocking density, similar access to shade and water. Do we need to separate those into two groups? Maybe not. Maybe they should be in one group, okay? So the other important thing, and this is continues to be in some data reporting groups, a challenge, and based on, if you're in a structure that's not a cow-based inventory system, getting all the calf data for animals that were actually born and raised on a particular operation. So selective reporting or partial data reporting is another way to describe it, can be a real challenge in the contemporary grouping structure. And that sort of selection of data that goes into the NCE has potentially an adverse effect on both that herd and the national system. And we'll talk through an example of that here in just a second. So again, this idea that contemporary groups really define what the average performance is that animals get evaluated against in that grouping in the national cattle evaluation really means that we need to get that mean or average performance record for that group as right as we can get it. Okay, so that means doing weigh-up conditions that are similar, so making sure we clean out the chute, that we collect data as clean as we can. That may mean that we actually process for weights. If we're doing a whole bunch of let's say we're doing some vaccination, maybe we're castrating the cull bulls, or we've got a really extended period of time that animals have to stand in lairage before they go through processing. The calves at the end, let's say we're processing 200 or 300 head, the calves that have been standing out in the pen or in the alleyway in the sun all day are going to weigh less than the calves that went through first because of shrink. And that kind of bias affects the genetic evaluation. So it may be more pragmatic to actually just go through and quickly weigh everything as the first step of the day, and then go back. It's an extra step, I know. Everybody's eyes are rolling back in their head. Weber, the academics, saying we got to run cattle through twice. But if you want really good data and you're in a situation where you've got lots of things to do, it may be best to actually weigh those animals first. And I know from experience, if you've got a good setup and alleyway and digital scales, you can weigh animals really quickly. It may be worthwhile to do that the day before, and then the next day come back and do all the processing where you've got varying lengths of time that you've got to work on an individual animal, and that'll give you better quality data. Okay. Again, this idea that the average that we estimate affects every record and every animal in that contemporary group, and so getting it right is really, really important. Obviously, bigger groups yield better estimates of average, and I'll show you a picture of this in just a minute. And it comes down to just the statistics of estimating a mean, measuring data. And most people think, well, a mean's not an estimate. Well, it is, because we've got lots of error around each individual measurement, particularly, or possibly, and those come together to adjust or move what the real mean of that sample is versus what we actually estimated to be using a scale. Okay. Again, minimize things that affect your ability to get a good estimate of the mean. So again, this idea of maybe separating processing and weighing into two separate things, doing things like cleaning out the scale, good stockmanship, those sort of things can really improve the quality of the data in the evaluation. So I want to talk just, and I'm a lefty, so I like pictures of data and analytics. And so this is a normal distribution of the mean or the sampling error or sampling variance around a mean. And the idea here is that, as you take a sample of animals and start weighing them, you're going to have some variation that's associated with the error of the device you're using to measure. So that many of us is digital scale, and so that's a lot better than an antique bar scale, for example, where we've got some potential inconsistencies in measurement or scale of observation. But there's error in that. And so doing as good a job as we can to minimize that is a key component in building good contemporary group data. And I don't want to get too bogged down in this idea, but the other component to that estimate of a mean is the more animals we measure, the more reliable that estimate of the mean becomes. So you can think about, if we could just go pull, say we've got a group of 10 calves, and we're trying to estimate the mean of those 10 calves, and we just pull 2 of them out and weigh them and average those 2, is that going to be a very good predictor of the average performance of those other 10 animals or other 8 animals? Probably not. So there's 2 things here. 1, weigh all of them. That helps a lot. 2, the more animals that we observe, the better that estimate of the mean is going to be from a population perspective. And so you can see on this particular plot, it's the standard deviation of weaning weight contemporary group mean. And on the x-axis is the number of animals in the contemporary group. And you can see it's got a pretty rapid descent in terms of that standard error. And so, groups of 20 or so are really good. They minimize the error of that mean estimate pretty well. Groups of 2 or 3 or 4 aren't particularly that good because we've got lots of variation in terms of weighing conditions and fill and so forth that affects those animals. And so the more animals we pour into it, the better job we can do. Of course, it's sort of asymptotic here. The value of 20 more animals as we move from 80 to 100 is a lot different than as we move from 0 to 20. Okay, so there's a diminishing return here in terms of scale, but certainly as we get bigger contemporary groups, that estimate of the mean is more reliable. Okay. So again, back to the idea that we can make contemporary groups, or we can make too many contemporary groups, and if that makes lots of small groups, we actually lose statistical power in the genetic evaluation because of that poor estimate of the means of each contemporary group. Okay, so how are contemporary groups generally defined? Well, in general, the first step is calving ease and birth weight. We think about breeder herd code, year, season, sex, birth management code, and whether they're an embryo transfer calf or not. Likely included in that is were they a multiple calf? So were they single born, twin born, triplet, so forth. Usually our genetic evaluation system only includes records from single born birthing records. If we think about weaning weight, it's a subgroup of the birth groups then, so it's got all of the calving and birth contemporary group data, birth code, birth management code, then weaning management code, which may include pasture, depending on what your breed association calls that, the weigh date, and the weaning sex. So, in the cases of bulls to steers, that may influence the contemporary group designation, whether they were castrated pre or post weaning. So including that appropriately is important. As we go to yearling weight, it's all the birth and weaning stuff plus the yearling management code, yearling weigh date, and yearling sex. Okay. So again, if we've got gender change on males in terms of bulls to steers, that may drive differences in those contemporary group formations. Again, I want to point out here that you've probably noticed the yearling data is a subset of the weaning data, and the weaning data is a subset of the birth data. So these groups never get bigger. And so everything we do in management continues to subdivide these groups and make them more refined. And so keeping that in mind as we start assigning contemporary groups can be really, really important. Lastly here, ultrasound traits. So it's the yearling contemporary group criteria, which again is all the birth and weaning stuff, plus the yearling stuff. then yearling or ultrasound management group or code if it's different than yearling, and certainly scan date goes in there. And so you can see we can, at the end of the day, we may have, let's say we end up with 100 bulls on feed for the bull sale. Those may represent substantially more than one yearling or ultrasound contemporary group based on, these previous subdivisions as we move through. Okay, this is a slide, and I'm Ryan well, I'm going to say I'm going to steal it because this is a really good slide. Ryan made this, and I think it does a good job of sort of pictorially explaining some important differences in contemporary group formation. So we've got two pastures here. That's the green box on the left and the right. They share a fence line. The trees represent the relative location of shade in those two paddocks. They share a common water source at the fence line. You'll notice that they're blue and pink critters here to represent differences in gender. Okay, I won't say which one identifies which way, but there's blue ones and pink ones. Okay, it's a little political joke, but obviously gender is going to divide these into two separate groups. Let's say this is weaning data, and then we've got a critter in the left-hand pasture that's in management group 2. Why do you suppose he might be in management group 2? I'm going to say he's probably a sickie because he's coded in red. So something went haywire with that critter. Let's say he had bad respiratory disease. We treated him 4 times. He's a chronic. It's probably not justifiable or fair to leave him in the group and assign blame to his parents based on his poor performance due to health issues. And so we code him out as management group 2, and that forms a third contemporary group in that set of calves. Okay. If we look on the right, and Ryan, I'm trying to remember here, we've got 6, 12, 13 in the left one. Is there 13 in the right one too? Looks like it. Yep, 13. So it's equal stocking density, between those two groups. 13 head on each side. But do we leave these as, it looks like, the area is the same, right? The two boxes are the same size. They share water. So that's the same. Do we leave them in the same contemporary group or do we code them a different one? Well, my judgment would be, given the distance of the shade and the potential travel distance these animals might experience, if this was in eastern Kansas, shade's pretty important this time of year. We got a heat advisory for the weekend. It's going to be heat index over 110. Critters with shade are going to do better. Okay, and the closer that shade is to the water, tends to be a favorable situation. So we might think about dividing these into a separate management group and call them management group 3. And then, of course, the gender again sorts them into 2 separate contemporary groups 4 and 5. So this is a nice pictorial example of how we might step back and, from a 30,000-foot view, evaluate contemporary grouping structure and make good judgments about how we ought to management code those animals going into the genetic evaluation. Okay. One of the other areas that I mentioned earlier that was really critical to this whole data processing and EPD calculation idea is complete data reporting. And I know a number of breed associations either are in whole herd reporting requirements breed-wise or have specific programs for breeders to enroll and be engaged in cow-based inventory system and whole herd data reporting. And that was really motivated by this recognition that, the historic fee structures for breed associations in some ways provided a disincentive, an economic disincentive for producers to report data. Every time we charge them for something, they look at it and go, well, is it worth $3 or $5 to send in a weaning weight on a calf that's a cull? On face value, some people go, well, it's not worth the $5 because I'm sending him down the road anyway. For the serious performance data analyst, it's absolutely worth the $5 because it affects contemporary group structure and contemporary And so here's an example of the impact that partial data reporting has. And this is actually a table that exists in the BIF guideline that I helped put together a number of years ago to illustrate this idea that, you know, only reporting the top half of the calves, say the ones that are going to make the bull sale, what impact that has on the performance records and the contemporary group deviations calculated for each one of those calves. And so if you look down on the left column, you've got calf IDs 1 through 10, okay? And you've got their adjusted 205-day weaning weight. So this has got age of calf and age of dam and all the stuff in it, okay? And you can see then that those calves average 625 pounds, those 10 calves, the whole group. And if we take the individual calf record and deduct the mean from it, so contemporary group mean subtracted from each individual performance record, we get these set of deviations, okay, where all the calves are reported. So calf 1 has a deviation of -101. Calf 10 is 117 pounds heavier than the mean. So then if we go and think about it in terms of contemporary group ratio, which is a data point that also gets reported to breeders, these calves would have ratios that range from 84 to 119, okay? And so this would be kind of a typical spread we might see in a contemporary group. If we think about the breeder, though, that says, well, you know, those bottom 5 calves, I'm going to cull them anyway. I'm not going to send the data to the association. And remember here that the computer only knows what the computer knows. I remember distinctly a phone call when I worked at the Gelpie Association with a breeder that was complaining to me about a particular bull's EPDs and about you know, how the calves recorded. And so I start looking up the data, and I can't find any information on those calves because they didn't submit it. Okay, and so data that doesn't make it to the association and into the NCE, for all intents and purposes, does not exist. Okay, unless it makes it to the association, it don't count. Okay, and so contemporary group, whole contemporary group data reporting is really, really critical here. So in this example, over on the right side is that that subset of data that got sent in, and if we look at that, we see these 5 calves now have a contemporary group mean, so only the 5 calves got reported. So the contemporary group mean estimate now is, instead of 625, is 675. Okay, so the 5 best calves, or the 5 heaviest calves, have a heavier mean. That makes sense, right? But if we look at the deviations now, though, those calves get when we calculate adjusted performance record less the contemporary group mean, they've now got deviations that range from -36 to +67. Okay, so the ratios range from 95 to 110 on these calves. One thing that should stand out to you really clearly is now that calves 6, 7, and 8, when the whole contemporary groups reported, are above average calves. Okay, they have positive contemporary group deviations. When I only report the 5 best calves, somebody's got to be below average. Okay, it's those 3 calves. 6, 7, and 8 are now negative deviations, and they look inferior relative to the 2 best calves. Okay, so there's really an important lesson here, right? So we only submitted what we thought the data we thought on the best calves. We sort of shoot ourselves in the foot, right? Because now, instead of those 5 best calves being the best, I got 2 above average and 3 below average because I didn't send in all the data. Okay, well, you might wonder, well, what impact does that have on the genetic evaluation? So I did a little bit of Excel math, and I made this example really simple to illustrate the point. Okay, so I took the whole contemporary group, that's the WCG deviation column. Okay, and then the PCG is the partial contemporary group deviations, and you can see that's the same numbers from the previous slide. Okay, for this example, we're going to assume that these are full sieves all out of the same cow. Okay, which we know we can't have 10 calves out of the same cow. But to make the math simple for the interim EPD calculation, they all had the same sire and dam genetic merit. They had the same maternal effect, same permanent environmental effect. So that stuff, just think it's all constant. okay? So I wanted to say, well, what was the impact on that calf's EPD, interim EPD, because of bad data reporting? Okay, and so the WCG INT EPD columns, the interim EPD based, so it's adjusted based on contemporary group performance for each of those calves. And what you can see is the mean weaning EPDs to 35, okay, out of that math. And they range from, on the interim basis, then from a 24 to a 47. Okay, so the one that had the minus 101 weaning contemporary group deviation, he went down about 11 pounds in weaning weight EPD. Okay, the one that was really good went up, okay, about 12 pounds. Okay, but if you look at the next column, the PCG, so the partial contemporary group interim EPDs, they now, only the 5 heaviest calves reported, they range from 31 to 42. Okay, so the calves that 6, 7, and 8 that were above average in the whole contemporary group reporting, remember they got a negative deviation in the partial data reporting. What happens to their EPDs? They go down, right? They go below pedigree estimate because of their partial contemporary group deviation was biased, okay? What happens to the 2 best calves in the partial contemporary group? Well, their EPDs go up, but they don't go up near as much as they did in a contemporary group of 10 when they're in a contemporary group of 5. Okay, and so you can see the bias in that is it's applied equally across all 5 of those calves. They're 5 pounds below where they should have been estimated. Okay, is partial contemporary group reporting a good idea or a bad idea? I can't make it more emphatic that it's a bad, yeah. All the panelists, bad idea, right? This is, I think, one of the most glaring issues I think we face in genetic evaluations, partial contemporary group data reporting. Now, you might ask, well, are the EPDs, are they still useful? Yeah, I can still tell between those calves which one's the best and which one's the worst, but they're not near as informative as when we get whole contemporary group data. The rank's still right, but the spread is contracted, and the EPDs are not as good as whole contemporary group. Okay. I'll quit stabbing that horse. He's already dead. Okay. So another important thing to think about here as we form contemporary groups is a sort of a broad idea called connectivity. And it's really, how do we calculate EPDs across herds? And the way we connect herds is through pedigree structure. And so being able to provide relative comparison of animals across herds is one of the key features why our existing national cattle valuation system evolved the way it did, to take out the effect of individual herds and the management in those herds to get at a better estimate of genetic merit. So in this example, I've got 5 different herds and different bulls represented in each one of those herds or contemporary groups. And so we get to look at the relative comparisons of bulls. So for example, here in the 2 upper kind of left-hand blocks, so herd 1 contemporary group 1 and herd 1 contemporary group 2, so the very upper left and upper middle box, 3 bulls represented in each of those groups, bulls A, B, and C in contemporary group 1, and bulls B, C, and D in contemporary group 2. Well, in that case, bulls B and C are common to each of those contemporary groups. So we've got a pedigree connection to those groups. That enables us then to mathematically compare bull A to bull D through the relative comparisons of bulls B and C. Okay, so we can sort out the relative merit of those individuals across contemporary groups through those kinds of pedigree connections. So if you spend the time and kind of work your way through that, I can actually get to a spot where I can make comparisons between all the animals in these various groups because there's pedigree connection. In this case, direct sire connection, but what we sometimes need is sires or maternal grandsires to be those connections across various herd groups. But if you've had a herd where you've sort of been kind of off breeding on your own and not using any outside genetics, sometimes you can get a little what we call disconnected from the genetic evaluation. And if you do that over a long period of time, it can have that kind of group can kind of drift a little bit in terms of genetic prediction. So it's occasionally good to really use some high accuracy AI sires or older herd bulls that have been used in another herd, potentially to make those pedigree connections between your calves and other animals in the herd book, to make sure these are strong connections in the data to make those relative comparisons. Okay, other things that improve data quality, we talked about this idea of reference sire as one key strategy. So that can be a walking herd sire that's been used. Maybe you've got a partnership bull and you get fall use, and another breeder uses him in the spring breeding season as a way to connect those herds and across the pedigree. And that really allows much better comparisons of those contemporary groups across the data structure. Another key component in that is it's not really sufficient to have just one progeny out of those reference animals. Having a good representation, somewhere maybe if you're shooting for bulls and heifers combined, 10 to 15 calves from a reference sire provides a decent sort of connection across that set of group. And again, report all the calves, right? So if you're only reporting the best calves and those happen to be all out of the same bull, your contemporary group goes from comparison of multiple sires now to a single sire group, and single sire groups don't provide really any new information to the NCE, so they get booted out, okay, in some cases. So multiple sires is a really important construction of contemporary groups. Other best practices, make sure animals and data are reported early. We face still some challenges with folks getting data in the NCE in a timely way, and it's probably in some ways maybe a little less critical now than it was where we've got weekly evaluations versus a monthly or semi-annual sort of reporting schedule. But getting data in a timely fashion is really important. I still see some instances where a breeder has complaints about an animal sire moves a whole bunch. All of a sudden it's because, well, we reported 2 years of birth, weaning, and yearling data all at once, and well, what a surprise. The data influences the animal's EPD and it changes. If a breeder would have reported that data systematically as we moved along, we would have had earlier information about that bull's genetic predictions and likely seen some of that change much earlier in time scale than what we observed when it's all batched up at the end, okay? Report observations on all available animals. So again, kind of complete contemporary grouping, complete data submission, a key component, can't overemphasize that. And then here, lastly, accurately report management groups. So, keeping good inventories on farm about, what animals were in the same breeding pastures is a mechanism that works very well. What groups of cows were together at weaning time. So, in larger operations in particular, we may have cows spread out over 4 or 5 different ranches or pastures. Being able to complete and accurately report that information when we submit weaning data and not pouring it all in as one group and saying, well, that'll sort out. Report the data, keep the data, it's important, okay? So with that, I'm going to turn it back to Ryan, and he's going to talk a little bit about how these different data points actually get used in the genetic evaluation, and in particular, how we think about these as multiple trait sort of models and how they influence each other. So Ryan, thanks.
Yeah, thanks, Bob. Yeah, so now we've gone through maybe what phenotypes or things you're looking to collect, maybe the best way to submit that data and information into the genetic evaluation to be able to inform that genetic evaluation to the best of your abilities. And I think it's always good to review why we collect the data and where that data, I guess, kind of goes in terms of genetic prediction for each of these different traits. And so kind of as we think about at birth what those separate are, those couple data points that we look at collecting at that time point, and we look here at what EPD analyses that those time point or those phenotypes are used in. And so obviously we would think calving ease observations would be used in the calving ease EPD, but we also additionally use, you know, the birth weight information on those animals to help predict Cavanese direct and Cavanese maternal. As we think about, you know, that birth weight phenotype, you know, generally most are not generally, weight traits are genetically correlated to one another. And so, you know, we use that in a multiple trait model to help predict all of the different weight trait EPDs. So that's birth weight, weaning weight, milk, and yearling weight and average daily gain. In addition, you know, by that calf having that cow having a calf within that year, and that calf being reported to your breed association, that also contributes to the stayability EPD and knowing that she was able to successfully reproduce within that year. As we think about, you know, weaning data, again, you know, we had a list of traits that we were looking at, you know, kind of possibly collecting around that time. Again, you know, those traits would contribute to our weight trait type data, our weight trait type EPD analysis, as well as those start being used as correlated traits into some of our carcass weight and ribeye area analyses, do their genetic relationships to those traits. And then, of course, if you're taking weaning docility measurements, that could be included into that EPD calculation process. As we think about, you know, some of that post-weaning yearling data, and for this, I'm, you know, kind of focusing on traits that we're publishing through IGS. You know, currently there's some options there to collect some other information. But again, you know, that yearling weight and ultrasound information would be contributing, you know, the weight information contributing to those weight EPDs again. And then that ultrasound information would be contributing to each of those different carcass EPDs. And then again, if we're collecting docility scores around that time, contributing to that EPD. And so, you know, as we see here, you know, collecting that phenotype information or even looking at some of these, you know, different things that we collect, we get a lot of mileage out of that information, and we don't just use it for evaluation of one EPD in particular. You know, we know for a long time that the best way to try to predict genetic merit is through, you know, multiple trait type models. And so we really try to, you know, maximize the amount of information that we can garner from that phenotype and use those phenotypes in different genetic evaluations. And so, you know, there's a lot of advantages to collecting that information and submitting that into a genetic evaluation. This was a graph that I had pulled together, and just kind of as trying to visualize kind of a representation of, you know, data that gets reported pretty commonly and maybe some that doesn't get reported as commonly. And you know, part of this is driven by, you know, birth weight, yearling weight, weaning weight, and yearling weight were some of the first genetic evaluations ever kind of conducted. And so this would be all animals, all, you know, throughout history. And so, you know, those were traits that maybe definitely got a head start on other ones. But, you know, we can look at that graph, and as we move down the side, you know, we definitely get the most weight data submitted to the evaluation. You know, as we look underneath the weight traits, then comes Cavanese, and again, like I said earlier, these Cavanese observations are on those of 2-year-old dams. After that, we look at docility. Then comes our ultrasound traits, genotypes, and then our actual carcass traits. And so, you know, as we can see here, you know, there is, you know, room for improvement across a lot of these traits to try to get, you know, get more data and information on more animals contributing to those genetic evaluations and really trying to, you know, improve those predictions on animals through that phenotypic data, you know, collection. One thing that, you know, as I was getting ready for this presentation that I thought would be, you know, kind of an example of why we want to try to collect all different sources of information. Some people may think that, well, I collected one weight, it's heavier now, it should be heavier in the future and heavier for all time. Well, that's not necessarily always the case, and it's really important to try to collect all of these phenotypic measurements and submit all of that data. And so what I did here is I pulled up an example of some cows from our database that had weaning weight, yearling weight, dry matter intake, and mature weight recorded on them. And so, generally these are traits that are highly positively genetically correlated. And so we would assume that, like I said, the heaviest ones at weaning were the same at yearly, also had the highest intakes and the highest mature weight. But as you look at this graph here, and I just ranked them from heaviest to lightest, so the heaviest animals here would be up on the top of the graph, and the lightest animals here would be down at the bottom, and I did that for each of these different time points. But as you see here, every crossing of the line here is a re-ranking of where that animal ranks for each one of these traits. And so kind of my take-home message here is, we can only record this, and we'll be able to predict what we think they'll be at these different time points based on how they perform for weaning weight, for example. But if we don't get accurate and complete reporting for all of these other traits, we won't be able to see where these lines cross and see what these differences in performance are. And that I think that becomes really important, because it doesn't allow us to maybe show some of these more favorable examples of animals that were heavier at weaning and yearling, but had dry matter intakes that were below where they were from a weight standpoint, and as well as mature weight observations. And so collecting and reporting all of that information, can help us better identify within those genetic evaluations maybe some of these more favorable examples. And those are animals, as you think about a selection index and our multi-trait index, if these are the true underlying genetics of an animal's progeny, being able to characterize that, these are going to be, maybe the animals that rise up to the top of our indexes. At the same time, we also don't want to be able to, or we want to be able to identify animals that don't have, some of these favorable relationships that maybe we are shooting for, where they're a little lighter at weaning and yearling, but high intake and high to moderate mature weight compared to those other animals. And so, unless we get all of that data and information into the genetic evaluation, that's the only way we're ever going to be able to predict these differences among those animals. And so, it's vitally important to include all of those different metrics and submit that data and information. What another example or another question I get is, is recording more data and information, does that really benefit me? And this was a comparison that I pulled together a little while ago in terms of, recording genotype and ultrasound information and our ability to make progress in those traits. And so within each of these graphs, the gray line represents animals that have both ultrasound and genotype information contributing to the genetic evaluation, and the orange line here represents animals that do not have that information. And so, carcass weight, maybe these animals on the orange line, contribute a certain percentage of them, contribute a yearling weight observation, but still this gray line here is steeper than that of the orange line. Back fat, able to keep that pretty constant. I would say, within Red Angus, that's been our general trend over time. They had the ability to do that. Looking at marbling, we start seeing here, 2014 on, we really start seeing those lines starting to diverge from each other. And so we're starting to make a bit more genetic progress in terms of our marbling EPD here. But really probably the most dramatic effect, within any of these graphs is our ribeye area EPD. And we can see, especially here in the last several years, those animals that have contributed both ultrasound and genotype information have really been able to excel, and that makes sense because our ribeye area EPD are our ribeye phenotypes and measurements, and of course the resulting EPD is generally a little higher heritability than what we see for marbling and back fat, maybe some of these other traits. And so you're able to still make more genetic progress, but contributing all of this information definitely helps you to do that. And so, I've been rambling for a really long time, and if you haven't finished your beer and need another one, you probably should go do that. But if anything, I'll say this, this is kind of the way I look at it is, accurate data collection and submission equals more accurate EPD information, which allows you to make more genetic progress. And, really for you guys, at the end of the day, that allows you to make more profitable seed stock for your commercial customers, and that's what we're trying to do, as seed stock members. And so submitting this data and information is really important for us to be able to work out my last equation here. And so with that, I'm finished up, and I'll turn it on over back to Jackie, and we can kind of go on.
Well, thanks, Bob and Ryan. And are you two gentlemen available over the next hour if we continue to take questions? Good. All right. So I wanted to make sure that we have some time to give our breeder panelists some time to speak and tell us their approach. So we've got 3 gentlemen on the line here, and they were recommended by 3 individuals that work with their breed associations. And so again, we have Kevin Porter from Porter Ranches in Alberta, and you might hear screaming in the background. My 3-year-old is having a tantrum. She's a door away, but I can't shut her off. So Kevin Porter came highly recommended from Sean McGrath, who's also on the phone or on the webinar with us today. We have Toby Jordan, who was highly recommended by Matt Wolfick and others, a shorthorn breeder from Indiana, and Bob's nodding his head because I think Bob has even extra connection with Toby, right? And then we have Casey Santa with Wolf's Cattle, and we might not be able to see Casey's face, but he's with us still, and he was recommended by Tanya Amon and the folks at the limousine at Now. So anyway, I wanted to give each of you 3 gentlemen a chance to just give us a little bit of background of your operation and also your approach to data collection. Are you getting whole contemporary groups submitted, or just tell us a little bit of your philosophy when it comes to data collection and reporting. And Kevin, you're first on my screen, so I'm going to start with you.
Okay, thanks. So contemporary groups, I mean, we certainly try to keep them as large as we can. When we calve in a pretty narrow window of, say, essentially 30 days. The 85 to 90% of the cows would calve, and so that would be one contemporary group at the calving or birth data collection period. And then throughout the summer season, I would sort males and females so I could maximize the size of at least the contemporary group by sex, and try to make pastures of 30 to 40 and up to 70. And then, of course, once weaning happens, feed them in at least groups of 50 to 80. And then, of course, I would try to, once we get through the yearling period, ultrasound. I don't ultrasound all of my heifers, but I definitely try to create contemporary groups of 10 for sire groups. I've done them all over history, but I've been doing it for a long time, and I think mainly I'm just doing the ultrasound part to get a feel of the direction that those particular sires are going. So that's from a data collection standpoint where I would be, and definitely it's good to hear I guess the reconfirming message that the size matters when it comes to contemporary groups.
Thanks, Kevin. And we'll have some questions and we'll circle back to folks, but I want to make sure that we give each of our breeder panelists a chance to talk about their approach and their operations. So Toby, you want to go next?
Sure. So we're in Northwest Indiana and family farm and run registered shorthorn cattle. So some of the things that we've incorporated, we've always recorded all the weights on both sexes and had submitted that. And as we've incorporated now ultrasound in the last, I guess it's 20 some years on both sexes, that's enabled us to make some progress on the carcass side. But because of our location, our feed resources, we do feed all of the steer calves after we make those bull selections at weaning or thereafter. And so we've been able to capture a lot of the carcass data and feed those cattle here on the farm. So that's been pretty helpful for us to make progress on the carcass side of the equation. But it's a struggle in our environment to keep contemporary groups large. And, you know, our pastures do vary, and so that makes some of those sizes smaller than we'd like. But and I guess the one thing that kind of struck me as the two presenters were going through and capturing all this data, we used to get into that same problem that so many of us do, where we're missing something. When time you sat in your office and you started keying everything in, somebody was missing a weaning weight, or somebody was missing a academy score, it just by human error. And so we've had to dumb it down and make sure that we have systems at home that those boxes are all checked, and to make sure, you know, to ensure that we're getting everything recorded and written down correctly, or entered into a laptop, or whichever format we're using. But that's enabled us to make sure that when that record goes into our breed association, that we did take all the measurements that we were after.
Excellent. Thanks, Toby. Casey, are you still with us?
Yes, I'm here. Can you hear me all right?
We can.
Okay.
Hey, Casey, you want to tell us a little bit about your background and your approach?
Sorry, I never got back to my office, so I didn't get the video going, but I'm the seed stock manager for Wolf Cattle. We're based out of Morris, Minnesota. Our main ranch is at Atkinson, Nebraska, where we calve about 3,000 cows a year. About 2,200 of those would be registered cows, and about 800 commercials, which get treated every bit the same as what the registered cattle are as far as collecting data, just because we use our commercial herd a lot for research purposes. So we still collect all the data on the commercial cattle as well. I guess so in the springtime, just for an example, we'll calve somewhere around 1,700 registered cows. Those cows will be in roughly 10 to 12 contemporary groups, our breeding groups. We start calving in late January, early February, and calve till about mid-May. They then get broke down into into breeding groups. 2-year-olds are all separate. We try to run 3-year-olds separate when we can, where it works out, and again, make about 10 to 12 contemporary groups, 150 to 225 cows per group. and then that is their set group through weaning. Some of those groups, if they happen to run next to one another and we set it up to wean at the same time, we will combine those groups if they've been running like situations. Just because even though we have pretty good size to our contemporary groups, once you break that out to bulls and heifers, and for us, they get broken down by limousine and limplex. We also run some Angus cattle. So we try to keep those contemporary groups as big as possible where it's suitable. And when we get, once we get to yearling time, we're usually looking at about 600 heifers, 600 to 650 bulls. And again, we try to keep those, I mean, they actually become more like one contemporary group at that time. But of course, they even though we may go to weighing it or whatever at the same time, they still go back to those originally contemporary groups. So as far as ultrasound, I mean, we've been doing ultrasound for a long time. We also try to collect as much actual carcass data as we possibly can. We feed out all the steers and send those in to get actual carcass data. Heifers get ultrasounded. The fall group of heifers gets ultrasounded. About 3 years ago, we decided to forego the ultrasound on the spring heifer group just from a cost standpoint. We figured that we were training the markers well enough with the ultrasound that we did on the bull mates to those heifers. We decided to invest our money in genomics instead of ultrasound, and it just kind of cuts out one step and saves us a few dollars. So we collect a lot of data. It doesn't all get collected by the same people. You think you have a pretty good handle on it, and you know how to do it and why you're doing it, but you have to constantly train and go back and refresh and make sure that everything is getting done the way it needs to be done. So we actually collect probably far more weights than most. We collect weights at pre-weaning, we collect weights at weaning, and we collect weights again at like 4 weeks after weaning. So we just keep tracking those weights to make sure that everything is correct and everything is progressing the way they should be.
Excellent. Thanks, Casey. I guess one question that I have rolling around in my head, given the talk today, and we've got a couple of questions from other folks too, but just to get this started, I'd be interested to hear from Kevin and Toby and Casey, from your perspective, why aren't breeders submitting entire contemporary group data? And I'll say, you know, Bob had talked about that whole herd reporting systems have been developed, and, you know, the interest of capturing all this data, and that's definitely true, but I can speak at least from American Simmental Association's perspective. Whole herd reporting doesn't necessarily mean whole contemporary group reporting. We still have people coding whether or not a cow had a calf, but we might have 50% of the herds sending in whole contemporary group weaning weights, for example. So I'm just wondering, what, maybe from a breeder's perspective, what are hurdles that would prevent breeders from sending in that data or collecting that data? Anybody want to go?
This is Casey. I think there's like I think one is a lack of comprehension of how the system actually works, and also the value, and then also maybe in some cases, I think we get we lean too heavy towards the top end of our cattle, and people worry about those. and they get the work done on those and think that they're doing it right. And as Bob alluded to in his presentation, they cut those contemporary groups down, and they think that they're helping those top few animals, when in essence they should be spending a little more time and recording everything, and they could really help those top animals. So I think I think a lot of it's just lack of comprehension of how it actually works and how things are actually figured.
Assignment of blame.
Yeah.
Make the bad ones, right?
Yeah, I would agree with that as well. I mean, I think the other problem too is just understanding for sure, but I think in ultrasound, people don't want to see, or like you can't market those smaller or poorer results. And when you get a negative index, I just think that they see the marketing opportunity is left on that, and they don't do it, and so they don't want to expose themselves to that spot.
I'm always feel that some breeders worried about the devaluing of the new Hertzaire, and so eliminate the bottom end, thinking that they're going to promote or continue to see marketing growth on a new Hertzaire or the new donor, instead of thinking about identifying a poor performer early on before they have an impact, whether that be within a breed or in a herd. But I think some smaller breeders feel that they can't absorb that mistake. And my thought is the quicker you know, the quicker you can make the adjustment within the herd.
We've got a question from our attendees about whether or not any specific breed associations, or I might interpret this question to say, BIF or any groups, are they putting together or determining optimal date range for collecting some of these traits, in particular weaning and yearling? And I know BIF has a spread, and Ryan shared the Red Angus's spread, which is very similar to ours as well. But having an acceptable spread is different than an optimal range. So if anybody on the panel want to address that?
I think the optimal is whatever fits your management, because the only thing that really matters is how they come out within their contemporary group anyway. So people get way too hung up on the actual weights, or even the adjusted weights, when the most important a lot of times is how they come out in that contemporary group. So it's something we deal with bulls that are raised in better pastures, or when we're comparing against bulls that are raised in a different part of the country that maybe have a better chance to excel pre-weaning, for example, than we do in the sandhills in Nebraska on mostly grass. So the main thing that people need to be aware of is that the big factor is how the cattle perform within their contemporary group.
Yeah, Casey, I think that's a great point, that having that really performance in contemporary group mentality, both in data collection but also in evaluation, is a really important perspective. Your point about the data collected and make it fit your management. Yeah, I'd rather take data collected 170 days, because I can get the whole group done then, versus somebody that's trying to coordinate calendars and says, well, if we wean them closer to 205 days average age in the group, we're only going to weigh half of them. Send me the younger data and send all of it, right? So work those out. I think there is some, you know, and maybe Tanya can speak to this a little bit. A couple of software packages kind of can help estimate those age spreads in the data, and so you know, just spending some time with your performance records, you know, and sort of work through calving dates and so forth can help you sort of target those optimums a little more conveniently. But yeah, the biggest thing is just collect all the data.
Anya, I think you're muted. Looks like you're responding, but you're muted. See if I can help. Oh. It looks like you're unmuted, but we couldn't hear you. You want to try again? Oh, we can't hear you. Sorry. Darn it. You could type in your response if you want to try that. Sean or Matt, while we're trying to figure out Tanya's audio, do you gentlemen have any questions or comments or thoughts from your perspective and things you hear often?
One of the things I think that I have a question, and actually the reason that Kevin came to mind was because he's a really good systems thinker and a lot of a really good understanding of what drives profitability. And I guess I would like some comments on, from all of the producer panelists, a little bit on data collection and not necessarily finding outliers, but identifying cattle where maybe enough is plenty in specific traits, and where that kind of fits in that complete data collection.
Jackie, this is Kathy. Tanya, if you have a phone number that came in your email, you can call on your phone to have audio. But then just one thing quick is there's a tab on your control panel. You're going to need to switch that tab from computer to phone. Okay.
Sean, asking about how much of a given trait, like how much yearling weight to find when enough is enough? Is that your question?
Well, yeah, like, so, I mean, we could take, for example, a trait like stayability or longevity, or a trait like milk, and how reporting those complete groups or doing that reporting influences, especially those traits. You're not just trying to find the outlier or prove that your bull's the biggest or the baddest in the breed. You know, you're trying to find some balance in the context of a whole herd and a whole system.
It always worries me, and my family just came back from a junior national, so I got to see evaluators select for just visual traits, and not to poke fun at the show ring, but that's always the one. I think as breeders, anytime we don't keep balance in selection, we inadvertently select against some trait that we don't know about, and I think it's obvious in the show ring or when we just use visual that we historically have made mistakes, but the same thing can be thought of when we select for extremes of anything. So that the outliers for us at home really work when they check all the other boxes in an acceptable range to some sort of idea of balance across all traits. We've watched the industry historically go down the wrong path, and I think most times it was caused by not keeping balance up front.
Sean, I didn't hear your question. Sorry.
Sorry, that hopefully this comes through. The question was really about balance selection and the importance and how that relates to complete data when you look at a production system, right? So if you're only measuring the best ones, are you selecting for balance in a system, or do you need to record the whole system?
Yeah, I would say for sure you need to record everything. I mean, I think that's how you probably get better number movement. I mean, I think you stay pretty static if you report your contemporary groups become too uniform. And I think, and that's somewhat of a negative point to EPDs, but I mean, if you've used EPDs for your entire career, I mean, and you start to see uniformity and consistency in your calves, you controlled a lot of those traits where you don't have incidents and you don't report any incidents because there is no incident. I don't think your EPD gets better.
Yeah, no variance in the contemporary groups means no change in EPD.
Yeah,
for traits like cavities or stability, that's the truth. So you got to put some kind of pressure on them somewhere to get that response. That's a great observation, Kevin.
But I mean, we're really trying.
Jackie, can I throw out a question to the breeder panel?
Yes, absolutely. And I think we have Tanya with audio now. So so Tanya, you might want to circle back on some of the comments made previously. But
I think we've probably moved beyond what I was going to comment on previously, but I was just going to follow up on, we seem to have circled back to those, more subjective scores or things like that. I get comments from breeders from time to time about being concerned if, whether it's docility or, as we move on down the road and get into feet and leg scoring and things like that, if what I call a 5 or what I call a 1 is the same as what you do. And the point is, as long as it's the same person doing it within the contemporary group, it's the rank that matters, not the actual number that you're giving. And, Casey alluded to that in his comments with regard to some of their locations. Certainly we expect the raw number to be different, but the rank within that contemporary group is the important thing. And, kind of staying on that track with, the Cavities discussion, if you have no Cavities trouble in your operation, selecting for more of it isn't going to get you anywhere. And so that was sort of the point. If there's no variation within that group, continuing to select for more and more and more is not moving the needle for you. So those were my 2 comments that and sort of relate, but sort of reverting back to a discussion that we've moved beyond by this point. So
I'm glad you're back on with us, or we can hear your voice at least. You hadn't left, but so Bob, you got a question for the group?
Well, yeah, I was gonna. We've got a group of breeders on here that are data engaged. That's why they're on the call, right? And so, I struggle sometimes with sort of we ask producers to collect a lot of data, and we add trait after trait after trait, and so we ask them to do more and more and more. How do you sort through and I have a sense a little bit based on our purebred unit here at the university, a little bit how we do it, but how do you guys sort through where to make genetic improvement investment? So, you've got a whole range of stuff. So you've got, the manual labor associated with collecting, cavities, birth weight, weaning weight, yearling weight, all those performance records, weight-based records. We've got, the ancillary stuff that goes with, if you're in a whole herd system, you automatically capture the cow exposure or the calving data and stability kind of information that goes with that. So that doesn't really cost any extra. But you can throw in ultrasound, and we've heard a little from a couple of folks about balancing that investment in ultrasound versus genomics. How do you sort all that out? I mean, nobody has a bucket they can just keep pouring money into phenotype collection. How do you prioritize that? Except for Toby. I know Toby just gets all the data.
I don't know. We try to concentrate on our bulk client base to understand what's important to them. And, I rely on those guys and their feedback. And we do spend a lot of time, whether face to face or on the phone, to make sure we know what's important to them. And if we don't need to be working towards a trait because we're not going to get paid for it, that one is going to slide towards the back burner a little bit. Right now, we're not getting a lot of calls for marbling. That's not been the driver in our market. We're going to measure it, but we're probably not going to invest as much in as some of the traits that directly affect our clients. They're wanting to keep a large portion of their daughters back. So we're really focused on trying to identify ways to select for those traits and put pressure on those traits and collect information for those traits that they're paying us on. That's the only way we can sort through all of the information that we have.
It does my heart good to hear that, Toby. I used to teach animal breeding on day number 1 to my students. I used to tell them that the seed stock industry exists as a business to provide service to their commercial customers. And on occasion, we can lose sight of that. So the fact that you led with that makes me feel great. I appreciate that.
I would say that, oh, go ahead.
It's Kevin. I would probably, focus on traits with probably the most heritability that would keep a phenotype really close to the middle. So I don't really want big cattle. I want cattle that will define the best value from a standpoint of being able to stay in a herd and be relatively valuable on a kill floor. I think there's going to be nothing special other than traits that will keep them in the herd and maximize their value in a feedlot.
Yeah, this is Casey, and I echo that. Our concerns are totally with what's going on with the customer, but to take that one step further, we probably feed close to 50,000 of our customers' calves out every year, which they have access to the carcass data on, and we review with them after closeouts. So it's totally based on the carcass. Yet we're not totally selecting for a terminal animal because we have guys that keep replacement females and that type of thing. But our environment where we raise the bulls in Nebraska, our cows have to fit that environment. So at one time we were based out of Minnesota, and we had a whole totally different type of cow herd than we do now that we're based out of Nebraska. So we select for a little bit lower milk animal and a little bit more efficient type cow, because we're basically grazing 10 months and feeding 2, where we used to graze for 2 and feed for 10. So we designed the cow herd to work in our production system, and the bulls are they have to speak for themselves, because it's going to come out on the closeouts whether they're getting the job done and we're making the right decisions or not.
I'm a little like Tanya. My heart's a little bit fluttered that the EPDs aren't just used for maximization, right? They're used for the optimization, finding that middle ground that fits in the production environment. And, it's not just a numbers race, it's a profitability race, and finding that balance of, is it cow efficiency in the weaning environment. If I've got customers that are feeding calves, I gotta have emphasis on end product merit. Getting that balance of trait emphasis is really important. And Kevin, focusing on traits that can I make more progress in trait A because it's got better heritability than trait B? A really important sort of decision piece in where do I place pressure and how much pressure do I put? Yeah, great. For the educators, Tanya and I, we're feeling good about the choice of the breeders on the program. This is great.
Yeah. So
I've got a question for the group.
Oh yeah, go ahead.
So from the association standpoint, we look at the amount of data we get, and I guess you can call us greedy. We always want more, whatever trait it is. We look at the percentage that we get from, if we get 1/3 of our calves get a yearling weight turned in, or whatever the percentage for whatever trait it may be. So I guess my question for you three as breeders is, what from an association standpoint could we possibly do to make it more worthwhile, or to get more breeders to turn in their information to the association to help fuel that evaluation? And I will say this to Toby, that I cannot guarantee that whatever your answer is can be implemented, but I'm still curious to hear what all of you have to say.
You've already heard my answer. I don't know the magic tool here to get more data turned in, because and I'm sure these guys will agree. I mean, those animals are coming through that chute for multiple reasons. I mean, we're going to wean, and they're going to come across the chute, and the scale is there. So, I don't understand when you hear complaints about, oh, we didn't have time or it didn't work out. Our animal herd health matches our performance program to make things simple. That's how we vaccinate and preg check. We do these things at these times. So I don't really know the answer exactly, Matt. Some don't see the value and the importance of making rapid change or hopefully improvement, like they should.
Is there any component that is the technology interface with the association that just makes it difficult to share that? Not so much that collecting it is the issue, but how the process of sharing it makes it difficult? Is there any part to that?
I don't necessarily. Yeah, I think that could possibly be a gain with just the way that people are evolving with the use of technology. Certainly, something that would work maybe better in the field might accommodate these people better. But I mean, I think we're talking about breeders that would have less than 50 cows, or they're smaller operations. So I don't think they're understanding, nor is their skin in the game the same for those of us that do it every day, all day, and try to figure out where we can capture extra value.
Yeah, it's interesting thoughts, and we certainly have the full spectrum of breeders. We have breeders that have large herds and large contemporary groups and large workforce to help collect data, to herds that have very minimal animal numbers. But what's interesting is how much of the database is made up from smaller herds. And so I think when we're thinking about these things, it's really important to think of ways to encourage good behavior across all those spectrums. And so I was just, we had a comment come in from Dr. Burt Moore suggesting that some of the reasons why the data is not submitted is due to shortage of time and labor. And that could be true on any size operation. I mean, the thing with larger operations is there's also a lot of other stuff to do, and it takes longer to run the calves over the scale or to collect all of that data. And sometimes it gets a lot more expensive to do some of those things as well. So I was just wondering, we're rounding the bend on the last few minutes, any closing thoughts on tips or encouraging concepts for breeders to find ways to collect whole pots of data and get that data into a system that enters into a genetic evaluation? Any closing thoughts from anybody, all guests on the group tonight?
I think it's really important to collect good data, and contemporary group size is certainly important. And the reality is the quality of the data, whatever it is will still add value to your cattle. So I think over time, that effort will be rewarded in the accuracies that you will get out. Now, whether you've chosen the right phenotypes is another question, but irregardless, good data will still show up in the long run. That's all I got.
Thanks, Kevin.
And that's pretty good, Kevin.
All right. Well, unless anybody has any other burning comments, I think we'll
I might
this
continue on.
Yeah.
Kevin makes a really good point. If you're not going to do it for your customer, at least do it for yourself, right? And there's the old adage, if you can't kid yourself, you can't kid anybody. But that speaks to the sort of the honesty and integrity of the data you submit. And really, if you're serious about genetic improvement, you got to be serious about the data collection, right? And there's just no shortcuts to be made in that. And so, the better or the more emphasis you place on quality data collection, the payoff for that is more reliable tools and more reliable information about your herd. So it's sort of a two-step piece, because when I say tools, I mean breed-wide availability of information. So the data you submit doesn't just affect you, it affects all the animals that are in pedigrees related to yours. And so if you want a better, more robust, more reliable system, part of that starts with making sure you submit the data and that you submit good data. That's all I got.
Thanks, Bob. Well, and I hesitate to bring up family connections, but I've certainly seen stacks of paper of information that just stayed on that desk or in that computer and never went anywhere else. And I just wonder how many pockets of those similar stacks are floated all over this continent. And even just, to me, it's a shame to have the information and not do the next step with the information. And so even if it's, hiring a high school kid that's looking for some extra hours to help get them entered somewhere, or, trying to get a little inventive with being committed, really, committing to data collection and committing to genetic improvement. And that means doing whatever it takes to submit that data. And so sometimes it's outside of our comfort zone, and I get it. It takes courage to push yourself to do something outside your comfort zone. But I think if you think about how committed you are to beef cattle improvement, then you better figure out a way to do it. Okay, well, we are at 6:59 on my watch, and my beer is almost empty, or my cold beverage is almost empty. And I just want to wholeheartedly thank our group of speakers, panelists, guests. This has been a great webinar tonight. I really appreciate all the conversation, and hope folks who are listening have something that they can take away with here. We will make all these recordings available on internationalgeneticsolutions.com. We will have another webinar in August about some improvements that are coming out of IGS focused on growth traits, so birth weight, weaning weight, yearling weight, and milk. And so we'll have a webinar in August. Date is tentative, so I'm not going to announce it tonight, but we'll, watch your email, watch Facebook, wherever you found out about this tonight. Tune in, and we'll have a webinar with Dr. Bruce Golden and Dr. Madi Sachi, and I'm sure we'll have other guests there to join in the conversation. So thank you all so much. Really appreciate you taking your time to be with us tonight.
Thanks, Jackie.
Thanks.
Thank
Thanks,
you.
everybody.
The sun is setting behind me. Can you see it?
A little bit.